True Credential offers you the flexibility to define the settings for your smart card. Now, let's look at an example where we create a custom chip profile in True Credential. For this video, we have set up both a credential design and workflow already. We will demonstrate the setup procedures that the True Credential administrator needs to complete so that True Credential can read from and write to the chip on a smart card. In this example, we will use a MyFair Classic smart card to demonstrate the following procedures to configure True Credential for smart card issuance. First, we will create a chip profile. Second, we will create a smart card workflow. Third, we will configure the personalized step for smart card reading and encoding. Fourth, we will choose the connection option that is appropriate for our smart card reader. Let's get started by creating a chip profile for our MyFair Classic smart card. The chip profile defines the type of smart card you are using, the amount of memory in the chip, the memory locations used for reading and writing, and the keys. Access the chip profile page in Settings. Here you can view smart card profiles that True Credential provides by default. You can use the default profiles for read operations. If you want to write data to a smart chip, you must create a profile. We are going to create a profile that reads from and writes to our MyFair Classic card. For this example, we're creating a profile for just the 1K chip. The profile we create will be used to read the card's serial number and to write the first name, last name, and employee number fields to the card's chip. Click Create. On the chip profile page, we type a name for this profile. Then we select the card type and memory size to match our smart card. We select MyFair Classic from the Type menu and 1K from the Size menu. We will not use the custom key application name for this example. Next, we define the layout for the chip. First, we configure the read operation for the card serial number. We need to add a card serial number field to this layout, so we click Add Field to expand the layout section. Here, we type the field name. Then, we select the field data format. The menu provides 3 options for the data format. For this field, True Credential is reading data from the card. Data encoded on the chip is always in hexadecimal format, so we select hexadecimal. Next, we need to select the location on the chip from which True Credential is going to read the serial number. We select the location S-00 shown in the sector number drop-down list. We need to select a key configuration for this sector. The key configuration list is empty, so we click the plus sign to set up the key configuration. The Manage Keys dialog for Sector 00 appears. Type a name for this key. It can be any name you choose. Do not use spaces in the name. Leave the default entry for Transport Key A. You must enter the 3-byte access key for the cards you are using. The card specification calls it access bits. Click Save. Scroll down and then click each of the bytes in the Block 0 row representing the memory bytes that True Credential shall read. Notice that in the layout table above, the block and bytes display under the location heading in the table. We have now configured the layout information for the card serial number. Be sure that you never write data to the card serial number's read location. Now we need to configure the layout information for the other fields. In this example, True Credential is going to write the first name and last name to the chip in alphanumeric format and the employee number in decimal format. We use the same chip profile to encode the chip that we use to read it. In the Layout section, we click Add Field and then type a name for the first name field. We select alphanumeric for the field data format. We select S1 from the sector number drop-down list and then select the key configuration that we created earlier. We select block B0 and bytes 00 through 15. We click Add Field to add the last name field and select alphanumeric. We will use the same sector as the first name field, so we use block B1 and bytes B0 through B15 for the last name. Finally, we add a fourth field for the employee number and select the decimal field data format. We continue to use sector 01, so we select block B2 and bytes 00 through 15 for the employee number data. Now that we have created the 4 fields and the location for their data, we click Save. The newly created chip profile displays in the table of available chip profiles. Note that at this point we have identified only the 4 fields. We have not configured whether TrueCredential reads from or writes to these locations. We will configure that instruction in the next step, where we demonstrate setting up a smart card workflow. In this example, we have an existing credential design and workflow in place, so after we create the chip profile, our next step is to create a smart card workflow. Choose Smart Card Workflows from the Design menu. On the Manage Your Smart Card Workflows page, click Create. At the top of the page, click Edit next to the workflow name. The Edit dialog box appears. Enter a name for the workflow. If you wish, you can also enter a description. Click OK to save the information and close the dialog box. Drag an operation to the Design area. The available operations are Read Operation and Write Operation. If the custom chip profile you use supports both reading and writing to the chip, you can configure 2 operations. For our example, we are configuring a read and a write operation. We begin by dragging and dropping Read Operation onto the Workflow Operations area. On the Operations tab, we select the chip profile that we just created from the Chip Profile Configuration drop-down menu. Then we expand the Advanced section. The supported fields list displays the fields we just created when we configured the chip profile. We want to select the field that TrueCredential will read from the smart card. We select the field that we created for the card serial number and then click Add to add it to the configured fields list. Next, we drag and drop Write Operation onto the Workflow Operations area. Remember, you must have a custom chip profile to write data to the chip. In the Advanced section, we add the fields for the employee number, first name, and last name to the list of configured fields. We click Save. The next setup procedure will point to this smart card workflow. Now that we have a smart card workflow, we can configure the workflow for our credential to read the smart card. We have an existing workflow that we are editing. First, we need to add the Personalize step. In the Steps tab of the Personalize step, we select the Chip Encoding checkbox. The Smart Card Workflow drop-down list appears. We select the Smart Card workflow that we just created. Next, click Field Connections. This is not the same Field Connections page that you used to connect the credential design to the workflow. Use this Field Connections dialog box to connect the Smart Card chip fields to the workflow fields. We connect the fields and then click OK. We click Save to save these changes to the workflow. Now we need to set up the connection to our smart card reader. TrueCredential offers options for connecting to different smart card readers, both contact and contactless. For this video, we are using an Entrust DataCard CD800 card printer using the Dual-I single wire reader. This connection enables the single wire connection to the printer which includes the smart card reader. To configure the printer for chip encoding, we click Settings and then click Printing. We have registered our CD800 printer already, so we click Edit. When a printer is equipped with the Dual-I single-wire reader, no driver installation is required. All we need to do is select the chip encoding checkbox. Note that the connection type is network. Now TrueCredential is ready to encode the smart cards using the workflow we created. Let's summarize the steps we demonstrated in this section. In this example, we had set up both a credential design and workflow already. We completed the following setup procedures so that TrueCredential could read from and write to the chip on the smart card when personalizing the credential. First, we created a chip profile because we wanted the ability to both read from and write to a MyFair Classic smart card. Second, we created a smart card workflow that pointed to the chip profile we created in the first step. Third, we configured the personalized step for our smart card reading and encoding by selecting the smart card workflow we created in the second step and connecting the smart card fields to the workflow fields. Fourth, we chose the connection option that was appropriate for our smart card reader, in this case the Dual-I single-wire reader. One of the many strengths of TrueCredential software is the ability to configure the system so that it is customized for your needs. When your credentialing program requires security, you can rely on TrueCredential.